Hello, in this lesson, I want you to find the real zeros of a polynomial function. I want you to find the complex zeros of a polynomial function. Some vocabulary we're going to come across are rational root theorem, or rational zero theorem, which is what we're looking at right here. Lower bound, upper bound, Descartes' rule of signs, fundamental theorem of algebra, linear factorization theorem, conjugate root theorem, complex conjugates, and irreducible over reals. So quite a bit of vocabulary we're going to start here. We're really looking at when you go to your next class, like college algebra or calculus, that you might get a teacher, a TA, or an old school professor. When I say old school, I don't mean old professor. I mean they believe in old methods. They say they don't want you using a graphing calculator. They want you to know all these parts of the polynomial without using a graphing calculator. So I'm going to show you how to do both. How to interpret it without using a graphing calculator and how to do it with a graphing calculator. And you have to do that same thing on the test. So on the first one, we're going to start here with a rational theorem. And what happens is when I have some sort of polynomial, what I'm going to look at is I'm going to look at the factors of my constant term, which I'm going to call P. And I'm going to look at the factors of my leading coefficient, which I'm going to call Q. As it turns out, all my rational numbers are going to be in that form of P over Q. That's the only possible ones I have. If Q happens to be 1, or whole, then you're going to only have integers. If you have something else, then we'll take a look at that. So let's start here with example 1. I want to list all the possible rational roots of each function. Then I want to determine which, if any, are zeros. So I start here by looking at all the factors of P. All the factors of P are going to be all the factors of 4. 1, 2, and 4. All the factors of Q are going to be 1, so P over Q is going to be plus or minus 1, plus or minus 2, plus or minus 4. So what I'm going to have to do here is to find the rational zeros. Is I'm going to have to check with synthetic division which ones work. I might have to do this up to 6 times to find all of them. Now, hopefully, after you find one, I know this will be quadratic, so after that, I can use my quadratic formula or factor it. Since I'm looking for just rationals, I won't be using the quadratic formula on this lesson. So let's check with 1. Is 1 a factor? So I go 1x cubed, negative 3x squared, negative 2x, and positive 4. So I bring down the 1. So 1 times 1 is 1, so I get negative 2. So I get negative 2, negative 4. Oh, look at that. Negative 4 is a factor. And not negative 4, but 1 is a factor. Then I've got a quadratic. So I've got x squared minus 2x minus 4. Rewrite that 4. That does not factor, does it? I can't find two numbers that multiply to 2 and add to. So my other ones are going to be irrational. So I only have one rational root of this polynomial, and that's x equals 1. Now I can check that by looking at the graph. This is how to do it without the graph. Let's take a look at the graph. Now if I graph this, and I notice, where are my zeros at? Well, I get x equals 1. That's one of my zeros. My other ones are irrational. So this tells you what you have to check. I would have had to check 1 no matter what. And then I'll check the others. Now let's try to do example 2 by yourself, and then come back and check on the next video.